Hello everyone, welcome to the YouTube channel of CUEE. The pandemic has lasted for years. I believe many of you have been experienced on using online meetings or online classes. Meanwhile, you may encounter a number of problems during an online meeting. Well, for me, every time I want to show something to the camera, I have to adjust the camera like this and waste a lot of time. So, how to solve this problem? Well, let's see how Apple solved it.
So, in the new iPad Pro, we're going to take a huge step forward by updating the TrueDepth camera system to include an all-new ultra-wide camera designed specifically for iPad. It features a new 12-megapixel sensor with a 122-degree field of view, which enables something really cool. And we call it Center Stage. Center Stage uses the new ultra-wide camera and machine learning to recognize and keep you in the center of the view. What's amazing is as you move around, it automatically pans to keep you in the shot. And that's not all. When others join in, it recognizes them too and zooms out to fit everyone into the view. So whether it's a whiteboarding session with coworkers or a family get-together, the experience of connecting is now more engaging than ever. So that's the new ultra-wide camera with Center Stage.
Now, we are going to make a face-tracing camera just like the Apple's one. First, we need computer vision, which means face recognition. The camera would recognize the user's face before moving, so it can trace your face. The Huskylens is an AI camera developed by DF Robot. It features several functions, including face recognition. It is very easy to use and it is compatible with several developing kits, including the Arduino. We are going to use it for our face tracing camera as the computer vision part. Before showing the details of how to make it, I want to show you the demo first. As you may see that at the top of the camera, it is the Huskylens. And at the bottom, unlike the Apple one, I use mechanical motors to achieve the movement of the camera, as it would be too difficult to do it in the software way. Now, I would like to teach you how to set up the Huskylens for this project. First, using the Select button on the top left corner, select General Settings in the menu. And then, in the General Settings, select Protocol Type, and you should choose I2C. And then save and return. Press Yes. Back to the menu, you would like to choose face recognition because we are going to use it later on. For face recognition, an unrecognized face will show a white square. After you press Recognize, a blue square will show as the face is recognized by the Huskylens. Other materials, of course, we need the Arduino, a webcam, also the stand for the webcam, including the two servo motors. Here is the wiring diagram for the project. Feel free to stop and take a screenshot. Now, I would like to explain the Arduino code for the face tracing camera project. Whether you have or do not have the experience on using Arduino programming, it would not be difficult to understand with the explanation. First of all, I would like to go through roughly about the whole program and how it works before discussing some details. The first part, we have some definitions which you would like to define the programming library, some hardware, and the functions and constants you're going to use in the later part of the program. And second, we have the setup part. It will be run once only when you turn on the Arduino, so it is called setup. After running the setup, the Arduino will run the loop part, and obviously the loop part will be looping itself infinitely. So in the loop part, we have most of the operation we are going to achieving the face tracing camera. And finally, we have the tool function itself. We are going to use in here in the loop part. So now I'm going to explain how it works in detail. First, we are going back to the setup part. Wire begins, it means we initiate the connection for Huskylens and the Arduino by using I2C connection. And then these 4 lines is defining the connection pin for the 2 servo using for the camera, and also given its original position we have defined here. And then we send the request to the Huskylens for beginning the connection. After we connected the Arduino and the Huskylens successfully, the whole program will jump to the loop part. So you can see that it's a if-else statement. The whole program is doing something like, if you do not request the block with ID 1, which is supposed to be the user's face learned by the Huskylens. If you fail to request the block ID 1, then it will wait and then request for the next time. If you successfully request it, then we will retrieve the first block with ID 1 to this result, and then we will have the coordinates, x and y coordinates of the block ID 1 with ID 1. And based on this coordinate, we will have to run this x and y servo chase, and let's have a look of what it will do. So for x servo chase, we will have to input the result, which contains the xy coordinates of the block ID 1, and also another value is the buffer distance. So if the x center, which means the x coordinate of the block you retrieved with ID 1, is larger than 160, which is the middle point of the screen of Huskylens, plus the offset and plus the buffer distance, it will return minus 1.5. What does it mean? Because it means if the block retrieved has a x coordinate which is on the right side of the screen, then it will return minus 1.5 for the servo. So basically it's doing something when the x coordinate is not at the center, the servo will have the corresponding movement to correct the image into the center. So these x and y servo chase functions are doing the most part of the face tracing. Notably, the x offset and y offset is used for adjusting the center point of the tracing, because the camera of the Huskylens and the webcam is in different positions, so you may have slightly some offsets you have to tune. And the buffer distance is to avoid the camera from shaking, because it is not exactly centering the image to the center itself. So we have a buffer zone, just like a square on the screen. When the image is entering the square, then the servo will not move anymore. That's it for the tutorial. Bye bye.